Okay, so now we're ready to go on to numbers of different kinds. Um, so in Python 2, when you would do division, this doesn't really matter to you guys because we're all going to do Python 3, but just keep in mind if you ever need to use Python 2, um, if you took the quotient of two integers, you would always get an integer, even if that value could be a decimal. So if you take 2 divided by 4, it's 0.5. But um, but Python 2 would say 2 divided by 4 is 0 because it's an integer divided by an integer has to be an integer. So now with Python 3, we don't have that problem. So we take 2 divided by 4, it's 0.5 plus 0.1, it's 0.6. So it works the way you would expect. And also we have parentheses that can be used for orders of operations. So parentheses get executed before multiplication, for example. So it's 2 times 4 is 8. So when we do string formatting with numbers, so imagine you have some numbers and you want to put into a text file, or you want to print to the screen, and you want them to be handled different ways. So we can have here we're going to generate an integer, floating point value, another integer, another floating point value, and another integer. And we're going to format these in different ways. So we're going to do, I'm going to use the old school style string formatting here, but we could update this to some of the newer formatting. So, but I'm going to print these outputs, and you're going to see how they get displayed. So here we have A, B, and C, and we're going to display those as strings. So C is really long, so it's 2 raised to the 100th power, so it's this big long string. If we here, what we're going to do is we're going to print D divided by E, so it's 1.0 divided by 4. We've written that out here, and we're going to display this as a double or an integer. So this is going to display as 0, even though it's a floating point value. If we display it as a %f, so again, most of what we'll do is %s, but sometimes we want to see different versions of how it's evaluated. So we can display it as an integer with the %d, or as a floating point value with %f. Due to the way that the computer handles floating point calculations, these are decimal calculations. There's some imprecision in the 10th or 11th or 12th decimal place, and so sometimes you'll see extra zeros, even though we know that 1 divided by 4 is exactly 0.25, right? It's not 0.250000, but due to the way that it's handled in the computer, that's how it shows up. So if we wanted to round that to 3 decimal places, we could do %.3, which means after the decimal point, we're going to have 3 decimal places of a floating point value. We could also use our raw format, which will give us, in this case, the exact way it's stored, or or the easiest one, the one that works for most cases, is just representing it as a string. And so that will evaluate that number and then just print the value as a string. You got to get kind of some experience with this before you understand how it all works. But so there's a few more modules that we're going to see today, and then we'll be done. So one is the math module. So in Python, when we want to use functionality that's not part of the core Python library, we have to import packages. So we have this command, import, and then a space, and then the name of the module or the package. So we import math and execute that. And now, in fact, we can add a cell here. We type math dot tab. It will give us all these math functions. So we can do sines, cosines, exponents, evaluate, log, pi, all this good stuff. So we have a function called floor, which will round down a floating point value, or ceil, which will it'll give a round up a decimal point value. We have a factorial function, which will give us the factorial. So 5 factorial is 1 times 2 times 3 times 4 times 5, which is 120. Or we can get the first, 12 or 15 digits of pi. We can get a square root of a number. And then so how we would maybe use all this together is we could save the value of pi as this variable called pi. We could save the square root value as a variable called f. And then we can print this expression using the traditional style percent formatting. Now, again, in the Jupyter Notebook, we don't have to put this print command, but if we wanted to export this code as a Python script and we wanted to see that output printed, we would need the print command. So there's another module called random, which we'll see briefly. So again, we import that. One cool thing about this random module is you can set the seed, which means we should all get the same values when we do this. So you get a random number. Are you guys getting the same value? Cool. So that's useful if you want to make sure your code is reproducible. But generally, you would want to set a random seed so that it was pseudo random. So there's some cool stuff with random. So you can have this function or this method called choice, where you give it a list, and it will randomly pick from that list. So the first time I execute that cell, I get 1, but if I keep entering it, I get a 3, and then a 2, and a 2, etc. So it'll just give me a random number from those choices. Or if I wanted a random number from 1 to 10, or actually I think this is going to be 1 to 9. Yeah, I'd get, let's just do range 10. This will give me from 0 to 9. Sure, there's a 0. Again, I can store some values using these examples, and then print the output using a print command with this traditional style string formatter. Question?
Is the range of the result from random always from 0 to 1?
Yeah, so the question is random.random always from 0 to 1? So again, we can type random.random. There's random int and rand range, so those are some other functions we might want to learn about. But this particular one, we can type random.random question mark, hit shift enter, and it says it's in the interval from 0 to 1. So this notation is not a Python notation. This is more of like a mathematical notation, so including 0 but not including 1. I believe if it's random int, this will give us a random integer from A to B, and if it's random range, choose a random item from range from start to stop. So let's try this. So I have to see if there's a way to do a continuous range, but another way you could do it is do random.random, and then times like 10 would give you a full floating point from 0 to 10, right? So,
I have a question.
yeah.
Can I just create 10 random numbers at one time?
Yes. Yeah, so you could do yeah, I think the way to do that would be to create a list of random numbers would be using, there's a NumPy function. I can look that up afterward, but I don't know it off the top of my head. You had a question?
Yeah, sometimes like they're pseudo random.
Mm-hmm.
If you don't seed it, it starts at the exact same number every time or something.
Yeah.
Is this one better than that? Meaning, like I know some of them are based on time in the milliseconds.
Yeah. I think you would. Yeah, there's a good way you can set your seed using. Yeah, I have to check on that. The best way to set your seed. Again, I think for a lot of purposes you'll use the NumPy version to generate random numbers,
Okay.
and that has its own seed generator. I have to look that up to how, like, what's the most safest way to generate a seed. Mm-hmm.
Is there a function where you can like randomly draw in like normal distribution with
Yes.
specific mean and like
Yes.
standard?
Yeah. So if you want a normal distribution, random distribution, there's a NumPy function for that also. So I don't think we're not covering NumPy today, but there's a whole lecture about NumPy. So you can generate a normal distribution, and it can be centered at 0 or centered at whatever you want. Yeah.
Thank you.
Mm-hmm. This random package is pretty basic. So for most numerical computing that you're going to do, you'll use NumPy or Pandas, which is built on top of NumPy. This is kind of pretty basic, but it gives you an idea. So just for fun, I made a magic 8-ball. So here's a list of strings. So we'll cover lists next time, I think, but a list is just it's denoted by brackets, and then there's commas separating that. So I can have this list, and then if I do, I'm going to make this go away, random choice. Let's see, will we have class on Wednesday? Oh no. Good. All right. You guys have to come to class. Sorry, that was close. So I don't know. Miss Cleo swears by it, so you can use a magic 8-ball. Finally, there's some help things. So we saw this question mark thing, so you can get information about a string. So this, I'm going to go out of order here a little bit, but for an object, you can also type this question mark. So this will tell us that this thing S that we just typed and hit the question mark is a string, has the form, it'll actually give us the string here if it's not too long, has length 4, and when we execute it, it will actually create a new string from the given object, which is kind of a property of itself. We can also get information about a single command. We saw this earlier, or about that seed function, for example. I'm going to go actually backwards here. So we already saw this. We type math, and then dot, and then tab. We're going to get all these different functions or methods. We'll call those methods. We can also type s dot, and will give us all the things we can do with this particular object. And then we can also get all the variables in a workspace by typing this magic command, %whos. So yours might look a little different than mine if you've entered in some different things, but these are all these variables that we have created in this session. It gives us the variable, the type, and then the actual data or information about that. So we have this S string, which is spam, this thing T, which is a string, and supercalifragilisticexpialidocious, and all these other things. So this is a really handy way to see what you've created. Now, if we close the notebook and terminate our Jupyter Notebook session, this will all go away. But of course, we can open the notebook up again and rerun everything, and it will all be generated again. So, so this is yeah, it's really handy kind of stuff. Remember to always use these, use this tab completion, use these question marks to get information. So you can Google things, and you should, but you can also get information directly in the notebook using these ways, and this can save you a lot of time, and often your question can be answered in this way. Any other questions? Yeah.
I think I figured out. We save it by just going file save.
Yeah, or there's this,
That
or
saves as like a text file.
up here there's this disk icon, and it says save and checkpoint, so that will save the notebook, and it'll also create like a checkpoint that you can, like, theoretically you can go back and to a previous version, and yeah, it will save it as a text file, which is .ipynb. The format is actually a JSON file, which is this like parenthetical type format. Yeah. Any others? Okay. Well, I'm here after class, but I'll see you guys on Wednesday.